So we've heard now about genetics, about environment, and a mechanism, one potential mechanism how these might interact. We're going to turn back to individuals who suffer from these disorders, and Deanna Barch is going to talk to us about how the cognitive symptoms of schizophrenia evolve through development.
Hey, great, thank you. So it's nice to back clean up because folks can set me up for some of the things I want to talk about. And so I'm really going to focus on, if you think about, we have to understand how genes and how the brain is leading to changes in behavior that actually create the risk for these forms of psychopathology. So I'm going to talk about the evidence in regards to early motor, cognitive, and neural predictors of the development of schizophrenia spectrum disorders. And Josh already set up the idea that there is a spectrum here. So when I say schizophrenia spectrum disorders, I'm talking about people who end up having a diagnosis of schizophrenia, schizoaffective disorder, and in some cases what people refer to as schizotypal personality disorder. So there is a spectrum here of disorders that people can develop that seem to be linked. And what I'm going to do is focus on the domains where there's the most evidence in regards to whether or not we might be able to see early markers, motor, cognitive, or neural, in kids in particular that might be predictive of the likelihood of them developing later schizophrenia spectrum disorders. And this is important because it gives us an opportunity to think about, are there early intervention points or pathways by which we can do early intervention and sort of shift people back onto a trajectory of healthy development. And for each of these domains, what I'm going to do is start by telling you a little bit about the prevalence of these impairments in people who already have manifest illness, because I think that gives you an important source of information about how likely it is these things would be useful in predicting the development. And then I'll say a little bit about what we know about how useful markers in infancy, early childhood, and even adolescence are in identifying those individuals who are actually at risk. So I'm going to start with motor abnormalities. And when we look at individuals who already have schizophrenia spectrum disorder, we see that approximately 50 to 65% of individuals have neurological soft signs that include subtle motor abnormalities. When you turn to think about predictors, what we see is that in infancy, indeed, neurological soft signs have some predictive utility. So for example, in odds ratios of 4.6, and importantly, it seems to be somewhat specific to the development of schizophrenia as opposed to mental illness more broadly. And we'll see that some other markers don't have that specificity like motor prediction does. We also see that the presence of unusual movements and postural abnormalities, even as early as infancy, also have some predictive utility in identifying which individuals are going to go on. And then we see in middle childhood, again, that neurological soft signs and motor coordination deficits also have predictive utility in identifying which individuals. And in particular, in childhood, motor coordination deficit seems to be relatively specific to the development of schizophrenia spectrum disorders as opposed to, again, other forms of psychopathology. Now, importantly, all of this data come from what we call case control or birth cohort studies, as opposed to familial high-risk studies. So familial high-risk studies are studies where you identify an adult who already has a disorder and then you track their offspring. Those studies are highly useful for identifying potentially good markers, but they're not particularly useful for helping us understand if you have a child in your office, you're a pediatrician, and you want to know, oh, am I seeing markers that indicate increased risk for developing a disorder? The birth cohort and the epidemiological-based studies are a much better way of identifying things that would be generalizable in the general population. So another domain that we know is important is cognitive function. So if we look again at individuals who already have schizophrenia spectrum disorders, we see that up to 80% of individuals experience cognitive impairment. And just to illustrate what that might look like, this is data from almost 5,000 individuals who've participated in clinical trials looking at potential agents that would improve cognitive function. And what we have plotted here are the percent of individuals who score below a T-score of 40. And that is considered to be an impaired range. And if you look across a range of different cognitive domains, you see fairly high rates of impairment across many different cognitive domains. But if you look on the far right at the composite score, which is really an aggregate across a number of different cognitive domains, here again you see that 80% of individuals show cognitive impairment. And I should note that this is just cognitive impairment compared to the general population. If you were to look at what you might predict their cognitive level to be from their parents' cognitive function or their parental education, you see typically even higher rates of impairment, because even people who maybe don't look impaired compared to the general population seem to be impaired relative to what you would have expected them to have given their family education and background. So now if you look at, does this predict, if you look at cognitive function early on, what we see in middle childhood is evidence that individuals who go on to develop schizophrenia spectrum disorders compared to their siblings show things like worse processing speed, so they're slower to do cognitive functions, and they also have poor working memory, or the ability to hold things online over short periods of time. And that's true even in high-risk individuals who go on to develop schizophrenia spectrum disorders versus those who don't. Now, we don't have a lot of studies that have actually computed things like odds ratios based on cognitive function, but there are some studies that have suggested that there is relatively good sensitivity so that you can, do a good job of identifying those who would develop schizophrenia, although the specificity to schizophrenia is not quite as high as you would like it to be. So you also see that it predicts things like the development of bipolar disorder as well. If you turn to adolescents, you can start to look at other kinds of markers. So for example, how are they doing in school relative again to what you would expect based on their family characteristics? And so here we see that worse scores in school than you would predict from family education also predict the likelihood of developing schizophrenia spectrum disorders. Now, IQ is another domain related to cognitive function but separable. And if we look at IQ or intelligence in individuals who already have schizophrenia spectrum disorders, we again see that a very large percentage of individuals have what we refer to as premorbid IQs, meaning the IQ they had before the onset of the illness, in the below average range. And again, it's even higher rates of impairment if you think about what it would have been had they not developed the illness relative to what their family's IQ level was. And we find that low IQ in middle childhood very strongly predicts the likelihood of developing schizophrenia in cohort-based and case control studies. And just to concretize that, what you see is that for each standard deviation increase in IQ, there's a 42% reduction in the lifetime odds of developing a schizophrenia spectrum disorder. And if you look at very low IQs below 70, you see an even stronger effect. It also, interestingly, seems to be an even stronger predictor if you also have genetic risks. So if you have a family member, typically a first-degree family member who also has a schizophrenia spectrum disorder. But importantly, it's not specific to schizophrenia. So it predicts the odds of developing a whole host of mental disorders. So high utility, but not very high specificity. Lastly, I'll say a little bit about neural impairments. So if you look at people who already have manifest illness, you see from meta-analytic studies that aggregate across many different studies that you see things like reduced volumes and thickness in regions of the brain such as the thalamus, the hippocampus, the insula, anterior cingulate, and the prefrontal cortex. These are consistent across studies. You also see things like reductions in the activity of the dorsolateral prefrontal cortex when people had to engage in cognitive tasks, especially those that tap executive function and working memory. And consistent with the synaptic work that was discussed, we see reductions in the connectivity among these regions, particularly reduced connectivity between the thalamus and the prefrontal cortex and the cerebellum, and actually increased connectivity of the thalamus to sensory motor areas. However, importantly, there's very little data on how well these things predict the likelihood of developing schizophrenia. There are some family high-risk studies, again, where you take offspring of people who had schizophrenia, and you see some similar deficits. You can look at clinical high-risk studies where people already have symptoms, and you see some similar deficits. But actually, there's very little data that has actually said, can we actually predict or estimate the odds of developing schizophrenia? So just to wrap up, next critical steps, we need better case control and birth cohort studies that look at a variety of different domains and assess specificity to schizophrenia spectrum disorders, and also to look at whether we get better predictive utility if we combine across predictors. So if we look at people who have both motor and cognitive and neural abnormalities, do we see better utility? And to do this early on in children and infants so we can really think about early intervention. And just as a shout out, There's a new study that's started, the Adolescent Brain and Cognitive Development Study, that will work with 10,000 kids across the course of development. And ideally, this study will provide relevant data that's missing in the literature about the predictive utility of these things. I'll stop there.